Hello, my name's Hazel Bradshaw, and welcome to my doctoral research presentation. This research is being done in association with the Human Interface Technology Lab of the University of Canterbury and Dried Frog Software and Game Development Limited. The research is focused on finding what is an effective design process for educational computer games. The research question being addressed is what is an effective design process for computer games that deliver structured learning activities. What we are looking for here is what is an effective design process, not what the most effective design process is. So what is wanted in this situation is not the most effective solution, but what is a possible effective solution. By effective, I mean that the students learn what is intended for them to learn through interaction with the game. And by design process, it's the process that game designers apply when developing said computer games. And structured learning activities are where a learning outcome is applied prior to the game construction, so that you have a structured activity with set goals. This research falls in the area of serious games. Serious games can be defined as a game designed for a primary purpose other than pure entertainment. Prensky coined the term digital natives. Digital natives are those who have grown up with technology, so from mobile phones to computers to the internet. So new approaches are needed to deliver learning. Presently in this field there's a separation between research and practice. In this research it proposes to develop an effective design process that provides a practical translation of educational design theories into applicable practice methods. We looked at some models of educational game design. These theoretical models of educational game design work very well at aligning learning theory. In this case, the theory of optimal experience, or flow. More detail on flow will follow later. These 5 models take a similar but ultimately different theoretical approach to how a game should be designed. None of these models offer the designer a practical way of taking the framed information and relating it into a real-world development strategy. Master's level research allowed the creation of a structural playability model. This model forms the basic framework for exploring the research question and acts as a systems approach to the problem of theoretical research into practical process. The following research looks at several learning theories: skill performance, flow, and motivation. Firstly, we'll take a look at skill performance. During the Masters, a game was created that applied skill performance into a game design. The basic game, as you can see here, was called Rasputin. It had several levels of difficulty that you could access, and it had instructions of how to start the game. It was a very simple platform game where the rules in the first stage were just to get to the top of the level. This continued, and as the gameplay developed, more tasks and harder skills were brought in. The theory behind this was called a theory of skill performance. This theory was translated into playability rules and phases of skill learning. The 4 playability rules, or principles, were that gameplay should follow a logical structure, that a skilled task should aid in the attainment of a goal. Goals should be made clear from the start of the task for the player, and the player needs a visual or tactile response to their actions, or they need to know how their actions have progressed them towards their goal. These 4 basic playability principles were combined with phases of skill learning. There are 3 phases of skill learning. In the case of a game, this would be easy, intermediate, and final or hard. These are cognitive, where the learner is trying to understand the task and what's being demanded of them. Associative, where new patterns of skill are utilised based on the skills already learned in the cognitive phase. And then the final autonomous phase, where the skills you've learnt are kind of become increasingly automatic. And at that point, you can start to go through the cycle again. In the case of Rasputin, we start with the narrative input. You need an engagement strategy. So narrative is used to outline the goals and to form a framework of engagement for the player, which gives the player motivation and a reason to progress. The gameplay should be logical, so you need instructions. It's a basic logical structure formed from the narrative. The game contains skill-related tasks, so you have in-game skill stages. So stage 1, as you saw, you just jump through the holes, there's nothing else in the way. Stage 2, you jump through holes, you pop balloons, so it's getting progressively and incrementally harder. Skill stage 3, you jump through holes, you pop balloons, and you avoid an elephant. Skill stage 4, all of these things combined, so you're building up incrementally your degree of difficulty. The phases of skill learning are reflected in the in-game playability structure. You can see this in the hierarchy of the difficulty levels. Each difficulty level also has a subset of levels which are skill stages. These skill stages make up actual levels within the game and become incrementally harder as more and more skills are added. Rewards and feedback. These are important engagement properties. They help towards motivation and progression. So in this case, rewards are popping balloons, seeing that your total is going up, that's for feedback, and then the congratulations, you've actually managed to do this, and then the score tables and entering your own name into the score tables. Really very simplistic model, but proved to be working and proved through research to be an enjoyable and engaging approach. So that's skilled performance. So let's take us back to the structural playability design model that was based upon. The structural playability design model in this iteration is made up of 3 stages. You have your high concept development stage, your gameplay development stage, and then your project management and assessment stage. In this first section, you see the narrative that is input into an organised sequence of activities that become the logical framework for the game. You're looking at the context of what the game is, the content of why the player is doing what they're doing, and how that's delivered. The why becomes the reason for undertaking a goal or a task, and the how becomes the game mechanic, so how that's actually going to happen in game. All that is based upon your end goal, and that's a cyclic process. So your skill phases should work with your levels. So at the beginning, you get relatively easy challenges, and the levels are relatively easy to navigate. This gets progressively harder as your ability to combine skills and tasks together reaches a pinnacle and you become autonomous. So what you have here is skill stages, which are made up of learning tasks. Each one of those tasks will give some sort of feedback, whether that's direct feedback or whether that's associated feedback from the environment, from sound, from reward systems. And that will then push you into the next set of progression. So you'll complete a game mission, then you'll progress, and then you can achieve a new level. In part 2, we'll look at how skill performance works with flow theory and motivation.